to do it by hand, so we're just doing it really quick. Push our right first. What's n?
4.
4.
Times.
4 times the summation of x, y's.
So that would be
80. This is also actually a really good, I hate to be one of those teachers who's like, actually, this is a really good moment to think about this, but it's a really good idea to be able to use a complicated formula and understand what it's asking for. The summation of x's times the summation of y's.
12 times.
All right, on the bottom is 2 square roots. One of the square roots is 4 times the summation of x squareds, 46, minus the summation of x's squared,
12.
12 squared,
144.
144.
Wait, can you say that again?
So it's the summation of x's, and then you square it, and the summation of x's is 12. So it's 12 squared down there. All right, here is what?
4 times 151 minus 23 squared.
Okay. I'm actually not going to put this all in my calculator at once, as I would normally, because I think it's actually a lot easier to do it in 3 pieces. You could do this all at once if you want to put enough parentheses in there, but I don't. 4 times 80 minus 12 times 23. So the top is 44. And then underneath that 1 square root is 4 times 46 minus 144, which is 40. The other is 4 times 151 minus 23 squared.
You have to square. Oh, she wasn't. She didn't have the square.
All right, and that's a lot easier for me to put in my calculator, so I'm choosing to kind of do it little piece by piece like that, instead of worrying about all of the parentheses at once. Make sure you put the bottom in parentheses.
How many points should we go?
Uh,
I'm guessing 2.
let's do 3. I got 0.803.
Yep.
All right, now, this is what a common question would be on the AP test. They would say, figure out the correlation coefficient and then explain what that means in context to the situation.
Strong
Positive correlation.
So between whatever the x's and the y's are, which in this case, we don't have any context, but whatever it was, like how much food you feed a cat and how many kittens are in her litter. Okay, apparently it's a strong positive correlation. Is it a perfect positive correlation? No, but it's positive. It's definitely in that positive range. I think they have a. I'm looking really quick. I think they have a explanation of when something's considered strong and when is something's considered weak.
You guessing within 0.5?
What?
Guessing within 0.5. Like, I'm just saying out loud so I can see if I'm right or wrong.
I got it. All right, what correlation coefficient is strong?
What? That's weak.
Okay, so apparently they say strong is larger than 0.7.
7.
Larger than 0.7, or I guess what, less than negative 0.7? Somewhere in those extremes.
One's weak though. It doesn't go from strong to weak, right? Normal.
Moderate is that's cool. I do love stats. Oh, apparently it really depends on what you're looking at. Like in medicine versus psychology versus politics, they're all very different. Like medicine, they require at least a 0.6 for it to be considered moderate, and everything below a 0.6 is considered pretty much not important. But politics, if you had a 0.6, that's considered still very strong. Yeah, so I don't think there's an exact guide on how to do it.
That's fine, the psychology one.
The psychology one is moderate through 0.4, and then weak after that. Here, I'm gonna stop my recording for Jasmine, and then you can look at it if you want.
You can watch